Hello, everyone. Good morning, good afternoon, good evening, depending on where you are. Welcome to our third community call of Litmus. Um, Today, we have one different agenda item, and we also have a few new members joining. With that, let me start with the standard agenda that we typically have. So this is our community meeting notes that we usually follow. To introduce myself, I'm Mukkara, one of the co-creators of the project, and we have the core team, and also our community seems to have joined by a few more leaders from chaos engineering practices from different parts of the world. So as a customary note, let's introduce the new members on the call today. I see 2 to 3 different team members here. Durga, do you want to introduce yourself?
Yeah, hi everyone. Good morning, good evening. So I am working out of Intel here in Bangalore. So we are integrating this the storage solution, the MayaData solution in our product. Okay. So there I am the validation lead. So I'm going to experiment this chaos tests. So that's where I'm interested to join this session and learning this chaos engineering practices. Thank you.
Great. Thanks, Durga. Welcome. Sumit, do you want to introduce yourself? And also, I think you have a few more team members with you.
Yeah, sure, Uma, and thanks for conducting this chaos engineering best practices. So I'm Sumit, I'm principal engineer. I'm leading the reliability engineering best practices in Intuit, where my team is responsible for providing support for chaos engineering for our platform as well as our application. We've been in this domain from last 1.5 years, and we've been working mainly on other open source. Very recently, we came to know about the Litmus, and as we are growing our platform, we are trying to see that if there is a Kubernetes native way to implement. And thanks to Karthik, Jayesh, and Uma, we have got started, and we have specific requirement to work on that. So with that, I think I have a few of my team member also joined, so I would like them to introduce also. Vijay, go ahead.
Hi, I'm Vijay Thomas here. I closely work with Sumit Nagal and Intuit for the same initiatives with chaos engineering. I think we recently started exploring Litmus chaos, and yeah, part of it.
Thank you, Sumit and Vijay. Welcome to the community and to the project.
Thanks.
We have anyone else on the call that wants to introduce?
Hi, I'm Christopher from Argo AI in Pittsburgh. We just started looking at using Litmus, and Karthik invited me to give some feedback on the project and our use cases for how we're thinking about it. I've been bugging him a lot recently, so.
Great. No, you're welcome. I think that's how we are going to grow with a lot more feedback from the community coming in. So thank you, Christopher, and welcome to the community and to this project. With that, let's move on to the next agenda item. Today, before we go to the project updates, or if any other community member wants to talk about anything, we thought as a team, now that Litmus has achieved the state of 1.0, that's what this team thinks, and we're very happy to be proven otherwise. So we go and fix what it requires to be 1.0 for the Litmus project. So at least we started internally for our business using Litmus for our game days. Recently there was an exercise, and from this call onwards, we thought let's start using Litmus as a game day tool for the community as well. So for that, we're starting with a small game day, a live game day today that might take about 20 to 30 minutes. So let me talk about what is um, game day means to us. Let me pull that. So game day really, it's a standard process or a popular tool you can think of. It's really a process where we go and ask a set of roles in your organization where we're going to introduce chaos or a measured chaos, not a lot of components are going to be involved, but a few or one component is going to be taken down. And then now that it's prepared, we go and look at what exactly has happened and what is supposed to have happened, and is our system resilient, and then we document all the best practices. Then we decide when the next game day is going to be, and what we should be doing at that time. So that's as simple as what a game day is. It's the way chaos engineering is executed with more than one people, right? It's both the tool as well as a set of people coming together and doing chaos engineering. And why are we doing game days? Because we think Litmus as a chaos engineering platform or a framework is now ready to be used as a tool for game days, orchestrating the entire game day. And then why we are doing it now here live is just to show that if someone is not aware of it, and they can start practicing game days and then get benefited by it. And we can also ask our community members. There are many experts out there. We expect them to share their experience. These videos are getting recorded. All right, so if someone wants to learn about game days, they can go and review the videos and get benefited from that. So that's the basic idea of game day. And today we are doing our first game day, Litmus game day. So probably we'll keep tagging this hashtag Litmus game day from now on, so people can. Now, a year from now, we would have at least 10 game days for various different applications. And we are at the back end, we have expertise in OpenEBS as a team. So that's again open source tool. And Litmus was really born out of the chaos engineering that was started for OpenEBS project. So we observe chaos engineering practices for this project. So we do have some expertise. So let's do that is what we thought for the first game day, but it's not really limited to OpenEBS. If Sumit or Christopher, if you are following your application for chaos engineering, you can share it, or anybody else, they're welcome to share. So today what we do is OpenEBS has got multiple components. We take the control plane component and then introduce chaos. And we do have a chaos experiment specifically written for control plane of OpenEBS application. And then the idea is not really to talk about OpenEBS today, but talk about how a game day is done, right? So I think Karthik is going to go through a typical game day template, and we start executing and then see how we ended up doing that. So that's a new agenda that we added to the session today. And with that, we will be going back to our regular agenda, typically where we share the project updates. One of us will share, and or we can even take any other topic for this call. So I'd like to pause here and ask either Sumit, Vijay, Durga, or Christopher that do you want to speak generally about your experience, or do you have anything to share? Because that's the first preference, and then we'll fill the remaining time with the other agenda, either game day or the release updates.
So I neglected to add this to the agenda because I'm a little new at this, but I did write down a bunch of things I wanted to talk about. about sort of things that we were struggling with trying to get Litmus set up on our EKS cluster. And that's actually the first thing. Is it looks like Litmus seems to work fine on EKS, but it's also not listed as a formally supported option. Seemingly, no one's really tested it. It's not considered like something that you guys are really targeting. Maybe add that. Consider adding EKS support.
Sure.
That's the first one, because we use EKS pretty heavily, and it's definitely Amazon's investing a lot in that, and you know we've talked a lot with them about it, and it is a bit easier to use EKS than say to just roll your own cluster using like COPS on plain vanilla EC2. Anyway. Beyond that, the biggest thing that we're running into right now is namespaces. It looks like a lot of the examples and a lot of the testing was done with everything in the default namespace. And that just, in the enterprise, that's just not going to fly because it's not least privileges, right? You want your app and everything else to be in a specific namespace and have that be very easy to install. So I've been talking with Karthik about this, and basically, like one of the experiments manifest that you have to install from the chaos chart, it's hard coded to the default namespace, and it looks like Karthik is working on some ways to fix that. But I think this also pulls you back to probably needing to use Helm, because that's the solution for Kubernetes templating. And I could do a sed, or you could do kube control-n, but there's problems with that because it's no longer explicit, and it's not sed isn't a robust solution. I think we can all agree on that. And doing kube control-n then is no longer explicit. The thing you're installing from the internet it's not clear what it's supposed to be. So there's disadvantages there. The other thing that we would like to have is we want to install Litmus and the experiments, the custom resources in like maybe a administrator namespace like chaos admin, or even just the Litmus namespace, and then have whoever's running on the cluster be able to opt in and out of these experiments when they want to. Currently, apparently that's not the design of Litmus. It is to require the custom resources and the experiments engines and the app that you're testing all be in the same namespace. And that will work for us, but it is clunky because now, in order to tell another team, hey, here's how you get chaos, I have to give them a script rather than just say, annotate your service with this tag, and then all of a sudden chaos kicks in. That would be more ideal for us. Does that make sense? Any questions?
Yeah,
Awesome.
I think that makes sense, Christopher. Thanks for that feedback.
Okay, and then another thing, you have a node CPU hog. We would also like a experiment. We would also like a node memory hog experiment. I'm guessing that's not hard to create because node CPU hog already uses stress. And stress has a flag where you can pass memory instead of CPU. And then the other thing, one other question that I'm having is, eventually, as I'm collaborating with the community here, I'm going to need to clear this with my management and the legal department at Argo, because we don't want to be involved in any open source projects without that kind of visibility to the company leadership. And I was having trouble figuring out what license Litmus was released under. I couldn't find it in the FAQ. And I know there are different repositories, and presumably each one has its own license file, but what if they're all different? So if you could just add something in the FAQ that addresses what license it uses, that would be helpful for other people who come to use this project and want to know very quickly, can I even legally use this, right?
Mm-hmm. Yeah, that's an easy one to answer. Maybe it's not very apparent, but all the content, the source code, the docs, everything are under Apache 2.
Okay. Yeah.
Yeah. The bigger goal is to get this project into CNCF sandbox and then grow from there, so that we get broader community adoption. But thank you. I think if it's not apparent, it should be apparent to the new users, because that's the first thing that they will start looking at. Yeah, we'll fix that.
Cool. And then the other thing is actually related a little bit to the GameDay thing you mentioned, and I was about ready to ask that while you were talking about it, but you said you have to measure whether or not the GameDay is successful. And one of the questions I have is like, where is the metrics for the chaos? Like, is I know there's a monitoring agent that you can turn on, but I wasn't clear on how that worked. Maybe I just didn't read the right documentation, but does Litmus emit metrics as to what it's doing and that and the like?
Great question. Observability is a key thing in chaos engineering, and we did have some metrics that going into our other project called Director, but we need to build metrics into open source as well. That's a to-do item, Christopher. So probably I think we should create an issue, Karthik, and then get larger inputs from the team and the community on what should be the general metrics. We do have a Prometheus exporter that pulls up what is this experiment, is it pass fail, but we don't have at the moment have enough logic that actually comes out with a decision on the larger picture, right? How did this experiment cause, did it affect Kubernetes as a whole or not? That kind of intelligence or analysis is not there. And that's probably is a requirement as well.
Right, because the when I report these projects to my manager, I'll say, hey, I ran chaos on foobar service, and they'll say, great, did it help? Can you give me data as to what happened? And I'll be like, if I say no, then they'll just cancel it, right? Like, so so yeah, that is a very important piece. And then the next thing, and I think this is the last one on my agenda, is scheduled chaos. I figured out a workaround where what I do is I have a cron job that has actually kube control delete pod on the experiment engine. And it turns out that it recreates the engine and runs the experiment again. So that's a hack that will work for us in the meantime. But a formally way to run a cron to schedule the chaos would be ideal here.
Right. Yes. This again. Do we have an issue, Karthik, somewhere that scheduling of the chaos is needed?
Yeah, I think we could. So, Christopher, could you go ahead and create a requirement on?
Yeah, that's been on my to-do list for the past week. I haven't gotten to it yet. Yeah, I thought you had said that was somewhere in the backlog already. But if it's not, I'm happy to log another issue. I can actually go through and log issues for all of these things if you would like.
Yeah.
That actually would be nice, because even though I'm just making a note of it, It'll
Yeah,
be
I'm
awesome
gonna.
to,
Yeah.
yeah, just be an active community member, and then we would welcome all of it. And then, ideally, we all will be working together as maintainers as well, right? So, yeah, if that's okay, please go ahead and log these issues. And
Yeah, for sure. My
thank
alias on GitHub is cpitstick-argo. Not trying to hide who I am or who I work for. So,
that's great.
and what we're about. If people don't know, what Argo is working on is self-driving cars. We're supported by Ford and Volkswagen.
Great. No, that's going to bring us a wealth of experience from your side in how you manage applications on Kubernetes, what kind of chaos you need, how you use. So every new community member is going to be of huge value to everybody else. So that's great. And
Right.
thank you, Christopher. And should we call you Chris or Christopher?
I prefer Christopher, but either one, I'll respond to either.
All right. Thank you, Christopher. Anything else before we ask others to, if they have any agenda?
I think I've CPU hogged enough time at this point.
I know. I mean, it's a measure of community growth, right? So if we just 8 people are working among ourselves, then
All right. Well, okay, fine. If you want one more, then the opt-in and out of experiments thing. Right now, the annotation is you do kube control annotate litmuschaos.io/chaos equals true. It would be nice if you could opt in and out of specific experiments rather than the whole thing with annotations. That should, I'm guessing that should be an easy change, but you never know. So if the team if one team in the same cluster wants CPU hog and the other wants pod kill, they can do that and they can do it separately.
Right.
Yeah.
Awesome. Thank you. And going to the others, Sumit from your team, do you have any comments, experience, you want to share something? All right. Durga, just a poll on you before we go to.
Yeah, I very recently I started this thing, so till now I have not experimented much on that. So as I'm getting used to it, I'll keep on posting my comments.
Okay.
I'm in touch with Adesh and Ranjit.
Great.
Yeah.
Again, we are on Litmus channel on Kubernetes Slack. Please reach out to the community, and then we'll be lurking there. So with that, let's go to the game day. I am giving off the screen share to Karthik or Atul.
Yeah. It's probably just start off with the introduction to the game days before Atul can take over and show the actual demo. So thanks everyone for joining. I think thanks Christopher. I think we got a lot of feedback gold, I would say.
You're welcome. Yeah, we've spent about 2 weeks diving into this pretty deeply and trying to get it to work. So, and thanks for all your support that you provided. That was also great.
Yeah. Cool. So
we're definitely going to start using it. I think we have enough workarounds for now to be able to use it. But all of these things, take it to the next level.
Absolutely, yes. Okay, so coming to the game day, I think Uma did give an introduction about what game days are about. And like he said, it's more of a process. And Litmus is one of the tools you can use to do chaos engineering as part of a game day. So I pulled this template out from the internet from an engineer who has posted it called Michael Kehoe, who's using it in LinkedIn. It's a pretty interesting template. As you can see, there's some amount of metadata about the game day itself, who's going to perform it, and when it's going to be performed, tickets corresponding to a game day and the timelines, etc. And then there is this process of getting all the stakeholders involved in the game day. You speak to different people who are basically involved in maintaining the application and supporting it, importantly, and also put out a note to the users sometimes if you're doing it on production. We're doing it on a staging cluster, which is a mimic of the production system itself. And we've got the approvals from the respective team. And about the chaos implementation, so what we're going to do is basically introduce chaos in the form of pod kills on the control plane of OpenEBS. So as you would know, OpenEBS is a container native storage solution for Kubernetes. And it has its control plane, which is a set of stateless pods. And the data plane comprises of the actual data replicas, which are bound to the nodes and directly take care of the IO and data management. And the control plane, as you can assume, is helping provision the persistent volumes whenever there is a stateful application who has requested it via persistent volume claims. So what we're going to do is we're going to terminate the control plane pods, and the remediation is automatic because they are deployed as different Kubernetes resources. The Kubernetes controllers, like stateful set, deployments and daemons, it should actually bring them back. There should be no manual effort in trying to retrieve them, unless there are some worst case scenarios in terms of pods not getting successfully rescheduled, etc. And the impacted applications include any stateful app that is trying to provision persistent volume or trying to create a storage pool at that point of time when the chaos is actually happening. And the downstream affected applications are those end user apps or client workloads, which are sort of depending on the stateful apps themselves for the storage. So there is this section which is talking about the actual chaos implementation and has a summary of the impact. Then there is another section that sort of describes the impact in slightly greater detail. So the Maya API server, the admission webhook server, and the provisioner and the snapshot controller are what actually help create the pools and the volumes and the snapshots. So any requests coming to these components when the terminations are going on might result in a potential delay of close to 60 seconds. These 60 seconds is what we've taken up from the liveness and the readiness probes that are being used on these respective components. So we should be able to successfully proceed with the task at hand. That's the creation request by the end of this period, because the components have been written to reconcile and basically execute the requests as early as possible. And the worst case scenario is when these components do not get rescheduled at all. And that can happen if there are insufficient resources on the nodes. There might be other pending pods which might get into running state, and there might be no place or no resources for these pods to actually get scheduled afterwards. There can be affinity policies or taints on the nodes that have been done as part of some administrative tasks which are not helping with, which are preventing reschedule, or there might be actual software bugs which cause some crashes. And the other component which will also undergo a kill, and these are actually going to happen sequentially. The NDM is the node device manager, which helps discover disk devices, virtual or physical disks mapped to the nodes, and creates a block device custom resource corresponding to that device, and it helps in the creation of storage pools. So the hypothesis here again is there's going to be a slight delay in updating status or creating or deleting these block device resources, thereby impacting the state of the storage pools. And the worst case is that these resources or the operations are just not taking place because the NDM pods could not get back at all. So in this game day, we will focus more on the former, though we will actually go ahead and do the kill of the NDM as well. The experiment does that. But we'll focus on what happens when there's a volume creation request that's coming in when the pods are not really available, whether they sort of reconcile and the volume gets created or it does not. So there are some post chaos injection procedures as part of the game day where the impact is measured in terms of infrastructure, impact towards engineering teams, what was the variance from the initial hypothesis, and thereby what are the action items that can be derived and how to do the follow-ups, what are the supporting artifacts that need to be created. It could be CR, it could be change requests, it could be playbook documents, it could be any such thing. So this is just to introduce you to what we're going to do as part of the game day today. It's a mini game day, we can say. So I'll just pass the control over to Atul, who's going to share the steps that we're going to perform, and also demonstrate via the director online tool about how the visualization aspect of, or the monitoring aspect of chaos also is going to be shared. Are there any questions around the template itself, or we could go ahead with the actual demo? Okay, I'm sharing, I'm stopping my screen share. I think Atul, you can go ahead.
Hello everyone. So we will start with logging into director in order to visualize our clusters.
Can you speak a little louder, Atul?
So here we are in director, and we can see our clusters which we have connected. So this is my account in director, and I have connected two clusters. One is SRE dev cluster where some development work is going on. One is staging cluster. On this cluster, we are going to perform the LitmusChaos today, and we can visualize what happens. So we will go to the topology view, and we will see all the components are running fine.
Atul, probably might have to speak up a little louder.
So here we have this all the components in this cluster tabular view, and we are going to see the pods in the OpenEBS namespace. So we'll go to OpenEBS namespace.
I think, yeah, sure.
So we can see all the pods are up and running for last 1 hour on this cluster. So everything is working fine. Now we are going to introduce the chaos on the cluster. So I'm going to Litmus website. Here, so these are the prerequisites which we need to perform. So I don't have this Litmus operator installed, so I am going to install this Litmus operator on my cluster. So it is getting created. Meanwhile, we will see the second step. So second thing is to validate the chaos experiment CIDs, which is also not there. So we need to install that as well. I am going to install this as well. Okay. This will go into our OpenEBS namespace. So I will just apply this in OpenEBS namespace. Okay, that has been created successfully. Now we will move forward. So these are the criteria and detail of the experiment which we can go through, and then we have to create the RBAC. So I already had copied this RBAC YAML. I am just going to apply that one. We can see. Okay. So service account and rollback and rollback authorization has been created. Now we will move forward to install the actual chaos. This also I have already copied. I'm going to apply that one. So it has been created. We will verify. It will bring up pods in OpenEBS namespace. There are lots of pods.
Yeah,
So
you can see that it's already starting to
study. And meanwhile, we can deploy one new app in order to verify the things. So I'm going to apply Perpuna. In dev namespace. So as we can see, the pods are getting deleted and created. So this persistent volume is not coming up. It's in pending states. Once the pods will be in good state, it will come up. So here we can see that it is in terminating state. And my page server has been deleted and it is coming up. Once it will come in ready state, we should get the PVC.
Hey Atul, would you also like to show the status of these pods from the director?
Sure. So here we can go to direct and see. So here also we can see that the Maya API server has been deleted and created 2 minutes back, and the new pod which we have deployed is also here. And so there are some alerts as well which we get regarding that volume provisioning and all. So it has said that the volume has been created successfully. We are going to verify same in the cluster. If we go and check, so it's already bounded. We can check our application as well. So this was the Perpuna app which we have deployed and it came up successfully. And the chaos is going on, deleting different components. As we can see here, it has deleted a control plane validator. We can visualize this from our director as well, what are getting deleted and all. So you can see that this is a pretty big cluster. There are lots of workloads running in different namespaces and okay. let's see what are the OpenEBS components. So it is deleting and creating all the components. The OpenEBS admission server has also been restarted.
Cool. I think, would you also like to show the status of the chaos engine, just to get a perspective on what the state is? We could do a describe, or we could do a get minus o YAML. I think that should help us get the status.
This is the typo experiment.
Chaos experiment.
Misspelled experiment.
There's a CHAOS. And maybe we could clear the screen as well. Yeah.
It is
Okay, this is the structure of the experiment, the CR, which talks about the permissions needed to run this experiment and the environment variables that need to be passed. They can be set to defaults, or they can be overridden from the engine. The engine status, when we describe the chaos engine, I think we'll also see where the experiment stands right now. I think it should be completed by now. The chaos engine, kubectl describe of the chaos engine.
Typo on describe.
I think the engine is named differently. We just need to do describe chaos engine. No need to keep the name.
Chaos, not experiment, it's chaos engine.
Yeah.
kubectl chaos engine. Yep.
Yep.
No need of namespace, or we need.
Okay, the status says the experiment execution is successful and the verdict is pass. So the verdict here, as far as the experiment is concerned, is whether the components are all back healthy. So we've just passed a list of components for it to go kill and check whether they're back up and they've done their functions. So around this experiment, I think we can go construct a lot of very specific use cases where we can talk about how the provisioning requests have fared, what happens to the end applications, what's their status, etc., to arrive at probably something that's more meaningful in terms of experiment result. Also, the point that Christopher made was very valid about what metrics we need. How do we actually ascertain whether an experiment has really gone through and how it has impacted the services? I think one of the feedbacks that we also received and also probably makes sense is oftentimes the metrics are all driven from the application end. So we have, if you can have a monitoring solution that is actually showing up the application metrics, if we can correlate what is happening in terms of chaos at that point of time, if we can place the markers around when it has started and what it is doing and when it is ended, that in combination with the app metrics can be really useful to base our hypothesis on, to really check how we've performed as part of the experiment. Yeah, I think that was the demo. Thanks, Atul.
Thanks, Atul. Thanks, Karthik, for the explanation. And yes, I think the summary is we need a scheduler to orchestrate chaos and also a good metrics to analyze what just has happened, right? So I think they're going to be on our backlog. We'll be looking at them to get them going at some point of time. Any questions on the game day? All right. We do have some time left for Q&A in general. Otherwise, we'll just do a quick roundup on what was the release of 1.1 all about. Maybe 2-3 minutes, Karthik.
Yeah, sure. Let me share my screen. Is my screen visible?
Yep.
Okay. So just to recap what we did in the last month. So we released 1.1 on the 15th of this month. And the focus again was basically to help the SRE persona with more features to confidently use Litmus in their deployment environments. So one such requirement was to be able to support abortion of chaos. So let's say you've run a chaos experiment with a high total chaos duration and you want to cut it midway. You don't want to really complete all the iterations because of different reasons. Maybe there is some unforeseen increase in the blast radius, or there can be some other reasons why you would want to really stop chaos, or sometimes for the developers, even just for debugging purposes. So the abort was one of the features that we delivered as part of this release. And the way that we've done it, so you all know that Litmus is basically an aggregation of several subcomponents or services. There's the runner which orchestrates the experiment or manages the life cycle of the experiment. And then there are the experiment pods, the way you saw during the game day. And then there are some dependent or helper pods that sort of come and go to actually do the chaos injection sometimes. So there is a need to remove all these resources when you say abort. So we've used a method where we're passing the chaos lineage that is nothing but the chaos UUID. That's the UUID of the chaos engine CR resource, which is being passed as labeled to all the children, all the chaos pods, all the chaos resources. And when we patch the abort state, that is basically there is an engine state flag, which you can patch with values called stop. That's going to remove all the resources at that point of time. So this is the first step that we've taken towards supporting abort, and it works for a majority of the experiments. There are some experiments which actually trigger some processes within the target containers. And for those kind of experiments, we actually need to enhance the abort capability to go and stop those processes on the target applications before the chaos resources themselves die out. So that's something that we are working upon right now and should be available in the subsequent releases. The other deliverable was around increase in the OpenEBS experiments. So the experiment that you saw during the game day was also built as part of this process. So there is an OpenEBS chaos chart in the chaos hub that you can see, and it is now filled with more experiments for validation of pool chaos and also for aiding the OpenEBS user's journey. So at various points in the journey, there are experiments that you can use to validate the sanity of your setup before proceeding. So those were some of the deliverables. And we've started to add events. So you can see that the chaos engine, when you do a describe, you can see it talks about creation and removal of resources when you abort it or stop it. And this is basically the first steps that we've taken towards building more aids, monitoring or visualization or observability aids into Litmus. So there will be more events added in upcoming releases to actually talk about the actual steps where the chaos is being injected, what all happens when the chaos is getting injected. So those events also will be getting added. And there have been some improvements in the logging framework. We've migrated to Klog. just to help us with the ability to control the verbosity of the logs on the runner and the operator side. And there have been some schema changes. As you know, every release and every sync up, we sort of add to the schema that we have already to help with better ways to describe your chaos experiment. So in this example, in this particular case, we figured out that there is one category of chaos experiments which we like to call the infra chaos experiments. So these are experiments which have an inherently higher blast radius. So for example, Christopher was talking about node CPU hog. There are other such tests like the node disk loss and let's say a node drain experiment. So these inherently have higher blast radius because they impact more apps than one. So sometimes it does not really make sense to annotate applications for these kind of experiments. So there is an annotation check that we can set to false. It reduces the number of steps in actually getting to the injection of chaos. So that's a feature that we added this time. And it's typically used alongside another flag called as auxiliary app info. So sometimes, let's take the case of deployments like OpenEBS pools, which essentially are deployments by themselves. They are not so-called infra components like nodes or disks, but still they have a lot of dependent applications that sort of depend on the state of the pools. So you can actually choose to provide the state of application state, you can monitor the state of those applications dependent on the pools or dependent on the central app by specifying a comma separated list of namespace and label key value pairs here. That will help you get a stronger exit check for your experiment to see if really all the dependent apps are alive when you the experiment. The other enhancement was about being able to support config map and secrets to run the experiments. There are some experiments which need information, config information to be passed. Sometimes there are secrets that need to be passed, especially when dealing with access to cloud platforms like AWS or GKE. So earlier, we did introduce this in the previous release, but that was specific to the chaos experiment CR, and that was still defined at a namespace level. And even though it's namespace, it's still global in some sense that there are different applications within that namespace which might have to reuse it. So we wanted to do it on a per instance or a per chaos engine basis. So we've updated the schema to be able to specify information about what volumes you can pass, what information you can pass to the experiment via the chaos engine. So it can be done on a per application instance basis. And this one was mostly an enhancement we made to ease the life of the chaos developers in Litmus. So there are a lot of manifests, as you can see, the chaos engine, the chaos experiment. They're very useful in terms of being able to have a declarative intent for chaos. And the snippets are themselves very useful for users when they come into the docs, they can readily pick off it. But for the developers, any change that they make to the experiment or this schema might have to go and change it in different places, spread across different repos. So we have the docs repo, we have the charts repo, and then there's the Litmus E2E repo, which is now created to do the E2E pipelines for the experiments themselves. So there are several such places, and we felt it was eating into our productivity. So we've made use of the embed tool this time and centralized all the manifests into chaos charts repo. So that becomes the single source of truth for all the chaos manifests. And we are basically embedding this source, all the snippets here, into any other place where we want, so that we might have to go and change in just one place. And that way we avoid mistakes. So that was one of the enhancements that we made from a developer standpoint. So apart from that, there were minor improvements, such as optimizing the permissions on the operator and doing the E2E pipelines for the experiments. And we've also added an FAQ document, and we'll add more questions there based on what Christopher and others have been suggesting to us. And as always, thanks to all the contributors and users, David, Christopher, Laura, Aman, Sumit, for all the feedback that you've been giving us. I think we'll definitely take that and prioritize. And some of the other improvements that are upcoming are around new experiments for doing proxy-based HTTP or network chaos, and getting better documentation really. So, and adding more events, etc. So yeah, that was, I think I took more time. Sorry for that.
Karthik, that was a detailed list of additions. The team seems to be getting good contributions from the community, both in terms of how good it is or what are the gaps, etc. So very important. Community, please continue to create issues or raise what's not working in the Slack channel. So we'll continue to get them into the priority list. And that's all we have. If there are any last minute Q&A, we can still take them. Otherwise, I think we are good.
I need to drop off because I have another meeting to go to, but thank you so much for listening to my feedback.
Awesome. No, thank you.
Mm-hmm. All right, we'll be in touch. I'm on the Slack channel. So.
All right.
Yeah.
Thanks, Christopher. Thank you, Sumit, and others. Vijay, please follow us on the Slack, and if not, till the next meeting, thank you and bye-bye. Have a great one, guys.
Thank you. Thanks, everyone. Bye.